And now we have our next speaker on board, and it's Lucas Santos, Cloud Developer Advocate from Microsoft. Actually, again, we have technology lover, and since 2011, he works with highly available and scalable applications. I'm proud of you guys because have so much passion to technical issues is kind of cool thing. Lucas, I see you. You are with us, and I'm happy to invite you to our blog. Are you ready?
Yeah, sure. I'm ready. I'm very excited to be here.
Cool. Thank you so much. I'm really excited to hear your speech, and also I will be really excited to hear you answering the questions because you will be with us not only while you speech, but after you, we will continue with our Q&A. So I hope that you will have a breath and you will have a time and passion to answer all of those questions we have. So Lucas, keep rocking.
Okay, so let's go. Well, in this talk, we're going to be, exploring a bit more about dynamic environments using Helm and Kubernetes. Actually, both of my sessions here at Nodejs Global Summit will be about Nodejs, Kubernetes, and infrastructure. So I will have the same disclaimer I'm going to do at the junior track. Despite this isn't a fully focused Node.js talk, I think it's important for every developer to actually know a bit about infrastructure and know a bit about how your code is going to run, how and where it's going to run. So the aim of this talk is to take a real issue. This was a real issue I faced in, 2018. When I worked at a previous company, and this is how we solved it. I'm going to show you some demos. I'm going to show you some other websites with a few demos too. So let me introduce myself. My name is Lucas Santos. I am a cloud developer advocate at Microsoft. I'm speaking from Brazil, in São Paulo. It's night already here, and it's a bit chilly too. But these are all my social networks. Most of them you can find. Let me take the pointer here because it's easier to point. But most of my social networks you can find on my website if this thing goes out. So here now it goes back on. Okay, so this is my website, and you can find most of my social networks over there. Another disclaimer, this talk will be on Twitter. I forgot to upload the real slides and the updated slides on the platform here on Pine. So these slides will be on Twitter. As soon as I finish, you can go there and scan this QR code. And so if not, you can just go and follow me on Twitter and it's underlined static void, because Lucas is a very, very, very common name here in Brazil. So I never find usernames for my social networks. Let's start with something. Today we work in development teams, right? So a big part of the development process is analyzing PRs. Maybe being to huge companies, it's analyzing PRs, code coverage, code review. We had awesome talks about testing. As you can see, the previous talk was about testing coverage, and it's very cool. It's very big to know. Be sure that you are having your code tested and you are sure that your code runs smoothly. So most part of the development teams goes on this pipeline. So basically, you have a team. This team has, I hope, a code searched on a repository like GitHub or any other version control system. This code is uploaded to the repository. This repository triggers a test, automated test or manual test, whatever. And these tests produce a package, which we call staging, right? So the staging package goes to the Q&A team to test. So you're going to be testing the staging package, right? This is the real thing that you should do, right? But there is one problem, right? There is actually a lot of problems, but the biggest problem is when we have multiple teams working on codes, on related codes in the same application, in the same repository, right? So basically, let's put here two teams. Those two dev teams are working on a code that's versioned on the same control system. Like, let's assume that's GitHub. This version control system produces tests, and these tests produce staging environments, right? So then the first thing, let's call this team 1. I don't know if you can see my screen. Yes, you can. Let's call this team 1. So team 1 tests the staging environment over here. And then we have team 2. So imagine this is an application, it's being tested by someone. Then team 2 pushes the code over to this same version control system. Now I can use the pointer. So the same version control system. And then this version control system generates tests which override the staging environment. So now the dev team 1 is now testing the dev teams 2 code. So it's not testing the same code right over again. This was a very critical issue because when we have like several teams working together on the same application, mostly you have code being overridden by an overwrite by anyone. So generally, teams fight over this. So what's this solution? What's the perfect world on this, right? The perfect world would be to have like, let's assume we have like 3 dev teams. Let's make it a bit more difficult. The first dev team, all dev teams put the same code in the same place, and then this code generates tests, right? But instead of generating one single artifact, one single staging environment, we generate 3 separate staging environments for each one of them. So basically, we are going to be generating a green staging environment, the staging 1, the yellow staging environment, which is staging 2, and the blue staging environment, which is staging 3. Each one of these are full applications, right? So it is not a simple API or something. I'm talking about full applications with databases. I'm talking a full API with, I don't know, microservices, queues, and whatever, a lot of stuff, right? So how do we achieve this, right? Basically, when we're working with microservice architectures, we can use several tools, right? But I'm going to use 2, and these are Helm and Kubernetes, right? Kubernetes is, I'm going to explain right now what is each one of them, but I don't know how many of you have already used Helm or have already used Kubernetes back in the past or is using. If you do so, please comment here, send questions, send love. I would love to hear and would love to talk about Kubernetes with you. Well, Kubernetes, for those who don't know, I'm going to explain right away. It's a container orchestrator. So basically, it makes very easier to manipulate and to orchestrate containers into distributed systems environments. So it's way easier to not get, mad and crazy with all the things that is happening into a distributed system or microservice architectures, right? It was developed by Google in 2000. It's a series of 3 projects. It's Omega, Borg, and then Kubernetes. The first version was made available as public in 2015, I believe, and now it's donated to CNCF, which is the Cloud Native Computing Foundation. It's a very cool stuff because it's open source. And since 2015, we have Kubernetes open source and being used. So Google uses Kubernetes, Microsoft uses Kubernetes, and there's a lot of companies, huge companies using Kubernetes. It scales, it has the management version of scales, states, and it actually manages all the control plane for microservice-based architecture. So it's very cool to have it because without it, you will be like lost in some sort of logs and communications network. It manages also network for everything, right? So it's cluster-based, which means that instead of have one single huge machine, you have like tiny machines behaving like one single huge machine, right? So it has a master and a few nodes, which we call workers. It's declarative. What it means to be declarative. Let's imagine something. We are very it's very common for us to write. So you're writing a Node.js program, right? Node.js is an imperative language. So you tell Node what to do. You have to, write the commands and tell it what it is going to do and how it should behave. But instead, we have several declarative languages like SQL. So SQL is declarative language because you don't tell it what to do, you tell what you want. So I want to select every record from a table, and it does its magic and gets you every record of the table, right? But the thing about Kubernetes is that it is declarative in files. So you write files that declare what you're going to do in Kubernetes. So I want to spin up a service. I want to spin up an API. I want to spin up a network request. I want to spin up a server, whatever. It's all YAML files or JSON files, but YAML files. And this makes very, very easier to version those files. And also, these files allow you to script it. So you can create scripts that change those files and create templates and so on. But Kubernetes itself doesn't have templating or environment variable substitution. So if you have we call this manifest files. If you have a manifest file, a YAML manifest file, and you want to put a environment variable, let's say for the application name, which changes from part to part, like branch to branch, you can't do this natively with Kubernetes. You have to put it on separate bash script or so on, so you can actually do it, right? This is where Helm comes in. So Helm is kind of the package manager of Kubernetes. Kubernetes is based on files, right? So Helm packages those files. It's like NPM for Kubernetes, but it actually manages versions. So if you have a package, we call this the Helm packages, we call it shards, right? So all the files, all the manifest files are grouped into shards, and these shards are just folders where you can put stuff in. And it manages the installation of those folders. So if you have let me explain, an API, and this API has a deployment, a service, and some DNS rules. You can put all of this inside a shard, and this shard will be managed by Helm. So if you deploy a second version of this API, you don't need to reinstall it. You don't need to bring it down and up again like we did on VMs and so on. You can just Helm install any other thing, and it will override the API, but without taking it off. So you don't have downtime. This is because of Kubernetes, but Helm does this gracefully, right? So it does allow templating. So you can do templating in Helm. There's a lot of functions. It uses Go. Actually, something I forgot to mention, that Kubernetes is written in Go. So it uses the Go templating language, and it's very powerful. Helm extends this a little further, but it's very cool to use it because you can put environment variables. You can pass values into Helm. Okay, so it's very cool. It's the easiest way to create and tear down whole environment. So let's imagine for our application that we have a MongoDB, and we have an application, an API, and we have 3 or 4 queues like RabbitMQ, Kafka, and so on. You can package it all into one single chart, and you can just, as easily as you install it with using Helm install, you can tear them down using Helm delete. So it's very cool. Okay, so how do we start to do this? How do we started to do this back when we needed to do it? Well, first we create a Helm chart for every application we have, in every microservice we have, every environment we need. Okay, so this application needs to be completely self-hosted. It's a way to say, okay, because you can actually deploy an application, but if it depends on the database, you are going to need to put the database as a dependency of the Helm charts. This is cool because Helm allows you to create charts that depends on other images, on other charts. So you can actually make a chart, install another chart, just like NPM does, right? So we create Helm create name of the chart, and it's going to create this. I'm pointing to this side because my screen is on this side, so I'm going to point this way because I forgot this is the camera. So it will create this whole tree of files and whole tree of directories. So we have charts here. It's the directory I chose to hold all the charts. We have the demo app. The demo app is the name of my chart. The chart YAML is almost like the package JSON from Nodejs. And charts is the dependent charts within those charts. So let's imagine a Node.js package, and this package depends on another package. So in package JSON, it will have like a dependency on our Node.js package, and this package will have its package JSON and so on. So I can create charts inside charts, my own charts, and I can create, and I can just put like requirements for these charts if these charts already exist on the what we call chart museum, which is the NPM registry for Helm, right? So basically, chart is the package JSON. It has the name of the chart, the version of the chart, the description of the chart. The templates folder is where you're gonna put all the manifest files that Kubernetes need. So this is very cool because you can actually port a whole application to Helm without doing absolutely anything. You just take off your manifest files and put inside the templates folder. It's going to work normally, okay? And the values.yaml file is the full values you're going to pass through and to this manifest file. So basically, if I have like an application name and this application name is an environment variable, and I want it to have like the full name, I'm going to put it here in the values.yaml file. Right. So this is a chart YAML file, the basic stuff. So app version, the API version for Helm, app version, description, name, and the chart version. App version is the version of the app inside. This is rarely used. So this is the thing we just built. So our demo app has a MongoDB attached to it. So on charts, we have a backend chart. This is a front-end application. On chart, we have a backend chart attached. And this backend chart depends on a MongoDB. So we have MongoDB over here, right? And then we do Helm install and the path to the chart, right? But this is no use if we don't have a CI environment. So we need to do this automatically. We need to test it. We need to make sure our application runs smoothly without anyone touching it, right? So for CI, I've chosen Azure DevOps. We chose Azure DevOps because it's not because I work at Microsoft, because I didn't work at Microsoft then, but it's because it has the full environment inside it. It's like a full product with repositories, CIs, and a lot of stuff, and it integrates with several other stuff. It integrates with GitHub, integrates with Azure, the cloud environment, so it's easier for us. So it isn't already integrated with the Azure portal, so it's very much easier to connect all the stuff. It's very cool. It has a very intuitive system of creating pipelines, so you can create CI pipelines and multiple CI pipelines on the blink of an eye. It has a step store like GitHub Actions does now. So you can use GitHub Actions. It's pretty much the same stuff. And it's free for public projects. So it's very cool. There's something I'm going to explain to you later, but Azure splits the CI process into build and releases. So build is the thing that you do before release some stuff. So take that in your mind and hold it to this concept for a while. So I'm going to update my authentication. So I'm going to connect to my AKS service account. And this is the easiest part because you can connect straight to Azure using an Azure subscription. And I have the name here of my cluster. And this is what I wanted to show you. This is a build environment. So when you build stuff, you can actually, the build step is when you are building images, when you're building things that you do prior to release. So in this specific step, I'm building images. So I'm building front end, I'm building the back end, and I'm pushing them to Docker Hub. I'm going to show you the examples of this, the real code, in a few minutes. And this is the release pipeline. So the release pipeline is where you actually release the stuff. So I have the deploy to production, which deploys a whole environment to production. I have a deploy to a testing environment, so like an alpha beta channel. And I have the tear down release step, and you can see that it's not related. You can see there's no line here connecting the dynamic environment over here to tear down, because this is a manual step. I need to tear the environment down manually, right? So this is something running. So I just created a post. I created a push on my commit on my repository, and it's just deploying. So I'm gonna open the demo. Unfortunately, this demo is it takes like 40 minutes to run, so I had to record it. Let me see. This is the demo. Oh my God, I'm open on the wrong program. So let's spin up the demo on the right stuff. Cool. Nice. So here's what we're going to do. I'm going to create a new branch called Alpha, right? Alpha 4. And this branch is going to be my Alpha channel, my testing channel, right? So basically, what we're going to do is to publish this branch. And this is what I'm going to show you. There is no Alpha branch here, so I'm just creating a new branch. Yeah, I have issues with QuickTime. It's kind of awful. So basically, we're publishing it. And now we're going to create this environment, right? So when I publish this, on my Azure DevOps, I'm going to go on pipelines. I'm going to go and build. And on build, there will be this bump step. So I just bumped the version. And this is building for branches. So actually, what this is going to do, it's building the front end here. So let's just skip this. And now we're going to be seeing on our Docker Hub that there is no such tag on the image. So this is a full tag on the backend and on the front end. There is no Alpha 4 tag. And basically the whole objective, the whole goal of this demo is to show that you can actually deploy a whole environment, a whole single environment and a whole application using a Helm and Kubernetes with simple steps. And there's nothing you can do to change the code. So I'm going to show you this in a few moments, the code, and you'll see that there's no change you need to do on the code. So it's now building the backend. It has pushed the front end. You can see that when we reload the page, there will be an Alpha 4 here. So this is an Alpha 4. Then it's building the pushing the front end, pushing the back end. So let's skip this. Now on the back end, we have the Alpha 4 branch too, right? So this is the stuff. Now we go to the release pipelines, and the release pipeline is going to be deploying to the environment we want. So the rules I put here was if I push to master, it will be production ready. So I'm going to be deploying this to production. If I am putting on any other branch that start with alpha, this is going to be an alpha branch. So I'm going to create a new application using an alpha release. So this is Helm. There is just the deployment, the production app deployed. So this is the thing. And if I do, let me return. If I get the deploys that I have on my namespace on Alpha 4, you can see there is some deployments already created. So my application is being deployed there, right? So it's creating the containers. As you can see, it has already completed. It has already completed the job. And you can see that there is an ingress. And this will be the URL of my application. This is automatically done by Azure. So you can just go there and you'll see that there is no DNS zones. And now there is a DNS zone, you can see here. So it has created the DNS zones. And this is our application. So let me stop here for a while and explain something to you. This application is a full application. It's not the front end. It's not only the back end. It's not only something. It's the full application. It has databases. It has the front end. It has the back end. It has everything. So it's complete, right? I can do whatever I want here, and it is complete, okay? So what I'm going to do here, it's a ship inspection application using event sourcing and some things. So you can, I'm opening network here, so you can see that it is calling the real API. So it's a different API, it's a different service that you're going to be calling. Okay, so if we click here on a new ship or something, if you do like expecting ship, you can see that there is the API demo app alpha 4. So it is a new application. Okay, so I'm going to create a new ship here, and I'm going to create a new port. Okay, so it's fine. And this is what we created. So it's completely created over here. Then I'm going to do whatever I want here. I'm going to dock, I'm going to undock, I'm going to, you know, fiddle around with the application. And then I am pleased with this. I'm going to tear it down because I already tested. So I'm just going to deploy it, click deploy, and it's going to tear my whole environment down. Okay, so it's a very simple step to tear down because it's going just to delete everything. And when we list it, you'll see that there is an alpha 4 because it hasn't run yet. When it finishes running, like here, it has deleted. When they're going to run again the same command, you can see that the demo alpha 4 has been deleted. You will see that there is no app whatsoever in Helm again. So when we try to access this again, you will see that it's the full backend 404. So this is basically what we had uploaded, and this is gone now. So we can actually do things, and we can test, we can break this environment down. We can, I don't know, do this a lot of times. So you can spin a whole environment up. You can make it go down in like a split of a second, right? So there are some design patterns, there's some like common practice on this. Manual test environments by branch. So if you want to create your environments manually, every environment you create, it's manual. You should do this. You should create your release pipelines just to be automatic on master, or no if you want. And you have to create your test environments manually. This is very nice when you have several features that not all the features need testing like this, right? So you have like automated testing, you don't need to test it manually. So this is cool. The way we did it was automatic testing environments by PR on the release branch. So every time anyone created a PR on a release branch, it would spin up a whole environment, and every time the Q&A would test it, all the POs would test it, everyone would test it, and when we all approved it, when the PR was merged, it ran the teardown environment. So there was one single environment for each pull request in GitHub. So it was very nice and very cool to test it. And this is another thing. Without being on branch, so release branch, we also had a RC branch, our RC tag. So every release candidate we had would be a tagless RC dash the commit SHA. So the commit hash. So every time a new push had this tag on, we could create a new environment. This was an alpha environment. This has to be created manually, only for those who need it. And there's the, you know, all automatic, all stuff. So you can create testing out environments automatically by, you know, each version of your app. So that's very cool. And this hybrid thing we did when we started to do this. So there are some tips we learned over the way. Tearing down an environment is just as important as creating an environment. You don't want your Kubernetes cluster, you don't want your cloud to be cluttered with unused environment and unused Kubernetes stuff. This takes up money and this takes up time. Okay, so this clutters all the environment. You'll be very complicated to, you know, see stuff and see what you're doing, right? So don't do it. Tear down all the testing environments you have right after you use them. This is something. Have you ever heard that phrase that behind every warning, there is a story. So this is the story. Do not use the prediction database. Someone used this, and this wasn't a pleasant Thursday when we had to, rebuild the whole prediction database. Do not use prediction databases on different, like MongoDBs. Don't use a different database inside the MongoDB cluster, because it's going to be, it's going to happen. Someday, someone is going to use the database for prediction, and it's going to mess it all up. Not all features need feature testing, so you don't need to do it for every feature, right? So you have to be mindful of when you do this for every stuff and when you do it for some stuff, okay? Make this environment creation manual, like I said before, and do not use prediction passwords anywhere else. So this is not a story. This is not something complicated. So, but the thing is, when you're doing testing, you don't need the environment to have the same aspects as the production environment, just the same functionalities. But what I'm trying to do here is you have to keep your testing environments as simple as possible, okay? So if you can, remove passwords from databases in testing environments, remove passwords from a lot of stuff in alpha channels and alpha testing environments, because this is not needed, okay? Just creates complexity that will be someone's downfall, because someone's going to be using it and someone's going to be messing it all up because of this unneeded complexity, right? Keep it simple. And don't early optimize. If you don't need this right now, don't do it. You don't need to do it right now just because I'm showing you. This was something we needed because we have like several teams working on the same stuff like every day, and every day someone would pick a fight with another one just because someone messed up with the testing environment. So this is worth it when you have like customer service that someone actually goes to the customer and demos it to the customer, so you can create a whole environment to test it with pre-added data. So you can make your image like the MongoDB or whatever image, MySQL image, and add the data into the database before. So you just create a seeded database to use to that client. So that's very cool for salesmen and for people in sales that wants to do demos. It's very nice and it's very cool to do it. But if you really don't need this, there is no point on doing that, because it takes a while for you to create this stuff. It's not as simple as it looks, but it is a lifesaver when you want to have separate environments to test stuff. So before I go to the references, I want to show you the code, right? Because talking ship, I want to show you the code. This is the stuff I built for this test. So let me put it over here. So this is the repository you have. So you can go here and take a look. I don't know if the moderators will be putting this onto the chat, but if they don't, there is this link on the slides too. No problems. You can ask me right away. Okay, no problems. And then this is the application. So we have the backend, we have the front end. I'm just going to show you the code for the backend application. We have some. It's a simple Node.js application using TypeScript. You can see there is nothing different. You'll be able to see this because it uses Express and has like all the routes over here. Everything that you're already used to. There's nothing you need to do it to change this. So this is the simple application. This is the server start function. There is the package JSON here with all the stuff. So nothing actually different. But the thing that changed everything was this. So this is the chart repository. So this is my chart here. So this is the YAML that we're going to deploy, and this is the values. So this is my default values. These are all my variables. So this is the ingress host name. So this is the DNS application. So this is the stuff that goes into the URL, and when you're doing it. Then this is the node environment. This is the service ports, the images, and everything else. And these are the templates. This is what the manifest files look like for Kubernetes. So you can see these are all variables. These are all templates. This our namespaces, app names, labels, everything is a variable over here. These are my variables too. So you can see that this Helm supports functions. So it has a default functions and has a templating function that allows you to template the template. So it's very cool. So I have a templating here, which creates the namespace, the values, and everything else that goes over here, right? So this is something that I did. Let me just show you something. This is a Vue app from an application that has, I don't know if you noticed, but when you have like different branch, a different version, you have like the name of the app changing. So this is what I do to pass the name of the app. So this is the base URL and this is the project title. So you'll see like Alpha 4 in the home screen. Okay, and this is the service. So you can see that service is fully variable. So you can just copy this and put it in your project because it's going to work. Because it's just, you know, passing the right variables here. It's simple. And the ingress is also just variables, right? And here is the interesting stuff. Let me come here. This is a dependent chart. So when I install the demo app chart, it's going to install the backend chart first. But if it's going to look into the backend chart, if it has some dependencies. So it has a MongoDB dependency. So it's going to install the chart for the MongoDB first, and then it's going to install backend, and then it's going to install frontend. Okay, so all my charts here, or my MongoDB charts, you can see they all have values.yaml, and these values are scoped. So if you have a chart inside the chart, you can access all those values inside the main values YAML here. So this is the root. You can see there is a name here. So I namespace this. So there's a front end, and this is the backend. You can see this the same name of the chart, right? So the backend over here, and you can have like the MongoDB if you actually need it, because I didn't need to put variables over here. But if I had any MongoDB variables, I would put like a MongoDB here because it has the same name of the chart, right? So this is the code part, and this, what the hell? And this is the Azure DevOps view. So this is also public. You can access this on this URL. You can see it. Okay, so dev.azure.com, elsantos-projects- /helm-variable-helm-dynamic-envs, right? So it's on the references too. These are the stuff. So this is a pipeline. This is a build pipeline. So this is how I created it. We create like, I have a minute left, so I'm just going to manage the time over here. These are the sources. I can connect to all these sources, so it's very cool. This is the source I'm connecting. This is a agent, like a machine that's running, so I can create a machine that's going to run like an agent inside this, so I can put custom conditions. So this is my pipeline. I'm using a hosted Ubuntu, and this is my condition. So if the variables, there is some default variables in Azure DevOps. You should check out the docs. But the source branch starts with refs/tags, which means it's a tag. I'm going to run this production because it's like v something. And if I want to build for every branch, if the branch name starts with alpha, so this is the stuff. And at the end of everything, I put create the artifact and send them over to the release pipeline, right? I'm just going to show you the release pipeline very quickly because I have 20 seconds. So it's the deployment to production. So I'm going to just do Helm, install Helm, init Helm, and upgrade, right? So this is the command I'm using here. Let me just return to this part and pass the references to you so you can see it and you can, print screen or do anything. This is also some references that you can actually use to learn and understand. And thank you. This has been very fun. And if you have any answers, if you have any questions, if you have anything else, just let me know. Go to my social networks. You can ask the Q&A here. I will be eager to answer all your questions, and see you on a next opportunity.